Morning, grade 7. Today we're moving on to lesson 11.6, independent and dependent events. So we're learning about two different kinds of events that both fit into one category. So independent and dependent events both fit into what we call compound events. So you can think about compound, we often talk about compound words. A compound word is like a word bedroom, where we have two little words put together to make a big word. So you can think about a compound event is a combination of two or more events. So when often we're talking about probability with compound events, a usual example is a bag of marbles. If you pull one bag out of a marble and then you pull, not one bag out of a marble, one marble out of a bag, and then you pull another marble out of a bag, that's a compound event because two things happened. So it's not just pulling one marble out, that would not be compound, but it's pulling out two or more marbles. So those are compound events. So compound events are just when two things happen. So remember I said that two different things are going to fit into that category of compound? Let's talk about independent events. So an independent event is a type of compound event. All right, I'll talk about more about what it means in a second. So let's just do a little bit of review here. Here I have a bag of marbles, red marbles and blue marbles. If I asked you what's the probability, if I reach into the bag without looking, what's the probability or the likelihood, theoretically, that I would pull out a red marble? Well, I should see that there are 5 marbles that are red. So 5 favorable outcomes. Out of how many marbles in total? There are 7. So the chance of me pulling out a red marble is 5 out of 7. So in theory, if I reached into that bag 7 times, 5 of the times I should come up with red. Then the probability that I would pull out a blue is, well, there's 2 blue marbles out of 7 options. Okay, so we already know how to do that. But now let's pretend that it's a compound event. What's the probability that I pull out a red and then I pull out a blue? But the key word in this one is that I'm going to replace the marble. So again, picture a bag of marbles maybe on my desk. You reach in, you pull out a marble. What's the chance you pull out a red? Then you put the marble back in. And now what's the chance that you pull out a blue? Well, the way that we can calculate that is by multiplying the probabilities of red and then blue. So, oops, I got to switch back to my marker. So, first picture. First person comes up, they reach into the bag. The chance that they pull out a red is 5 out of 7. Then they put the marble back into the bag in this case. But then what we can do is we can think, well, the marble's back in the bag, it's reset, there's still 7 marbles in there. Now the chance that they pull a blue out of the bag is 2 out of 7. So actually the way we can figure out the chance of these two things happening in a row is we can multiply these two probabilities. So you should remember when you multiply fractions, you multiply the top and you multiply the bottom. So we do 7 times 7 is 42. I'm blanking out here. Yep, no, 49, sorry. So we get 10 49ths. So the probability of you pulling out a red and then a blue, where we replace the marble in between, is 10 out of 49 times. Okay? That's, again, theoretical probability. Now let's go back to why we call this an independent event. The reason we call it independent is because this last section here, we pull out the blue, is independent of my first step. And what I mean by that is because I replaced the marble, remember I put it back in the bag after I've pulled out the first one, then my second thing that I'm doing, pulling out hopefully a blue marble, is not affected at all by what I pulled out first because the bag resets itself. So they're independent. These two things right here are independent of each other. One does not actually affect the other because the marble went back in the bag. Okay, it might be a little bit more clear when we looked at dependent events. So let's take the same bag of marbles, but now we're going to work with a dependent event where we don't replace the marble when we're done. So same thing as before, probability of red, is 5/7. Probability of blue is 2/7. So now we want to know what's the probability that I pull out a red and then a blue. So I start with, well, I've pulled out a red. I have a 5 in 7 chance of pulling out red. But now I need to think to myself, I did not replace the marble. So I've pulled out a red in theory. So let me go up to my bag here. But I didn't put the marble back in. Now that changes what my probability is for my chance of pulling out a blue. Yes, there's still 2 blue marbles. But now look, my chances are 2 out of 6. Oops, I should probably write a 6 as I say 6 instead of 2. 2 out of 6. So because I did not replace the marble, the first event affected my second probability. So my second one over here is dependent on what happened in the first round. Then I still multiply, so I get 10. 7 times 6 is 42. So actually, if I don't replace the red ball, there's a higher chance that I'll pull out a red and then a blue. So dependent events are when you don't replace it. Independent is when you replace it and you reset it. So let's try that again with a couple ones. So let's do another bag of marbles. Blue and red again, but now there's different things going on. So I always just start with, okay, what's the probability of blue? It's 3 out of 5, 3/10. Probability of red is 2 out of 10. So this is an independent one. I am going to replace the marbles. So I can go, well, the probability of a blue and then a red, sometimes it's just written like this, blue, red, okay, is, well, I have 3 out of 10 chances of pulling out a blue. I put the marble back in because it's independent. So when I want to pull out a red, I haven't actually changed the probability of getting a red from before. So I get 3/10 times 2/10, and I get 6 out of 100. So you can actually see the chances of me getting a blue and then a red are pretty slim. Let's try that. Let's pretend we're doing, let's do red then green for a second, just so you can see. So again, remember we're replacing the ball. So their events are independent because they don't affect each other. So let's do the probability of green and then red. So I start with, well, green's the first one I'm going to pull out. I have a 5 out of 10 chance of pulling out a green. I put the marble back in, so I still have 10 marbles in my bag. So now I have a 2 out of 10 chance of pulling a red. And so I do 5 times 2 is 10. And 10 times 10 is 100. I can simplify. So there's a 1 in 10 shot of me pulling out a green marble and then a red marble. It's an independent event. Now let's do the same problem. So I have the same bag of marbles, but we're not going to put the marble back. So this is dependent. What happens in my first pull of the bag affects what happens later. So what's my probability of blue? Well, it's 3 out of 10, but now I've been instructed to not put the marble back in. So there's still 2 red marbles, but now I have not put the blue marble back in, so it's 2 out of 9. So I get 6 out of 90, which I should be able to simplify. I'm going to divide by 3, so I should get 2 out of 30. I would get 1 out of 15 if I did my simplifying properly. So these are dependent because what happened in the first one where I took out a blue and I didn't put it back, it changed what was left in my marble bag. All right, let's try it again, but let's pretend we're playing Scrabble and pretend that these letters are all face down in front of me. Okay, I have A, U, O, E, E, I, I. Let's just do some practice ones. What would be the probability of me pulling an A if these were all face down in front of me? Well, there's one A and there are 7 letters. What would be the probability of me pulling an E? Well, 2 E's out of 7. Okay. Now, what's the probability that I get an A and then an E where I replace the letters? Well, I would do 1 out of 7, which is the probability of A. I replaced it, so all the letters are back in there, times 2 out of 7. So I would get 2 out of 49. So you can see there's actually a pretty low chance of things happening one after another, because when you pick up a letter, first there's a small chance that it's an A, then you put it back in, then there's an even smaller chance that you get an E after that. So it is a very low probability of that happening. Let's do it with 3 events in a row, pretending we're replacing it right now. So what's the probability that I get a U and then an O and then an I? U-O-I. So the probability of a U, I'm replacing it every time, these are independent, is 1/7 times an O, which is another 1/7, times an I, which is 2/7. So I actually get 7 times 7 is 49. Then I should do 7 times 9 is 63. 4 times 7 is 32. No, that's not right. Come on, Miss Naif. 7 times 4 is 28. Plus 6 is 34. So I actually get the chance of this happening, theoretically, is that I could do this 343 times, and probably only 2 times with this exact order and combination show up. All right, let's do it again, but let's pretend it's dependent. So let's do the probability of E and then O and then I, just for fun. So, but remember, we're going to pretend right now there is no replacement. And your textbook will outline that for you very clearly if you replace it or not. So, probability of E, then O, then I. So E is 2 out of 7. But now remember, I'm not replacing it. So I've taken my E tile out of the bag. Let's say it's in a bag. Now, what's the chance of me getting an O? Well, there's still only one O in there, but now there's only 6 tiles left. So then I keep that one out. Now there's 2 I's left in there, but there's only 5 tiles left. Then I would multiply the top, and then I would multiply the bottom. So I could do 6 times 5 is 30, and then 30 times 7 is 210. And then if I wanted, I could simplify to 2 out of 105. Okay, so that's a dependent event where there's no replacements. Then you have to really pay attention to how many tiles are left. So when you're working in your textbook today, be very careful thinking about, are these compound events? And if they are they independent or dependent? Is the number of tiles or marbles going to change? Or does it stay the same because I'm replacing what I've put back?